All right, so let's talk about the periodic table specifically. Okay, when you look at a periodic table, you see several different symbols, you see several different numbers. What does it all mean? Okay, so we're going to take it back a notch a little bit and just kind of analyze what's on the periodic table. Okay, so say for example, the one I like to point out is carbon. Okay, carbon, which if you look at the periodic table, it will be have a nice being a nice square, right? Which that's kind of a nice square. We have essentially carbon in here, which is represented by C. Okay, this C here is a symbol for carbon. What you see to the top left, but sometimes you won't always see this here. This is actually what we call the atomic number. Over here we have the symbol. And then at the very bottom, which again, these sometimes switch depending on which periodic table you look at, you have the atomic mass, which is 12.011 in this instance. Okay, so that is what we have here. All right, and this here is my atomic mass. Okay, so in order to kind of analyze this a little bit further, what is this really consisting of? Okay, now that we know the breakdown of this, what is this consisting of? Well, when we're looking at an atom, we can break it down into several parts. We know the atom is going to be consisting of protons, neutrons, and electrons. The theory behind it, I mean, you can look through your textbook or the open source that's been provided to you. Let's go a little bit further. In general, when we're looking at protons, all right, are going to also equal the atomic number. Okay. Neutrons, which we'll get to in just a second, we actually want to go to electrons. All right. They're also going to equal the atomic number. Unless charge is present. Okay. Which that means if I have some type of ion, some charged particle, the number of electrons will change. Okay. If we're looking at neutrons, okay, a good way to know what the number of neutrons are is that we take essentially the atomic mass. Let's break that up a little bit. Minus the atomic number. That would give you the number of neutrons, okay? Now, there's usually a charge associated with all these. So protons, they're positive, electrons are negative. These guys are neutral, okay? The overall size, the overall charge, and so forth, you can learn in the text of the book. But here, I'm just showing you the basics of how we identify the number of protons, number of electrons, and number of neutrons. If we take this a little bit further, well, actually, let's head back a little bit. Well, all right, never mind. So if we take this a little bit further and we break it down, what that means is that when you change the number of protons, you change the element. Okay? When you change the number of electrons, you get a charge. When you change the number of neutrons, you get an isotope. Okay? That would be, say, for example, carbon-13. That would be an isotope because the number of protons didn't change, but the number of neutrons did. Okay, so that's how we would get an isotope.